chapter motion in a plane and topic average and instantaneous acceleration. Firstly, we discuss the average acceleration, A bar average. Firstly, discuss the average acceleration. The average acceleration in rectilinear motion or motion in plane is defined as A bar average is equal to V2 bar minus V1 bar divided by T2 minus T1, where V2 and V1 bar with the velocities of particle at time T2 and T1. This is the average acceleration. A bar average is equal to V2 bar minus V1 bar divided by T2 minus T1, where V1 and V2 with the velocities of given particle. Then this equation can be written in motion in plane, that is in two-dimensional case, V bar 2x minus V bar 1x divided by T2 minus T1 into I cap is the unit vector along x-axis, plus this average velocity along x-axis, and we write the average acceleration in along y-axis, that is v2y minus v1y divided by t2 minus t1 into j cap, where I cap and j cap be the unit vector along x-axis and j cap is the unit vector along y-axis. We define the average acceleration in case of x-axis and in case of y-axis. Then this equation can be written as A bar average is equal to, this is the average acceleration, or this is equal to A bar average along x-axis into I cap plus A bar average along y-axis into j cap, where A bar average x and A bar average y with the component, and value of A bar average x is V bar 2x minus V bar 1x divided by T2 minus T1, and values of A bar average y is V2y minus V1y divided by T2 minus T1. Now this is the average acceleration in rectilinear or in motion in plane. Now, what is the magnitude of this acceleration and what is the direction of average acceleration? Firstly, the magnitude. The magnitude of average acceleration will be, the magnitude of average acceleration will be a bar average, or a average, we consider only magnitude, a average is equal to under root a average x square plus a average y square. This is the a average x and a average y with the component of x axis and y axis respectively. And the direction of average acceleration will be tan theta is equal to a average y divided by a average x. A average y divided by a average x. That means the average acceleration along y-axis divided by average acceleration along x-axis, and the ratio of both acceleration is given as tan theta. This tan theta gives the direction of average acceleration. Now we discuss the second part, that is instantaneous acceleration. This is about average acceleration. Now the instantaneous acceleration is denoted as a bar, and this a bar or instantaneous acceleration, a bar, is equal to limit t tends to 0 delta v bar upon delta t, or a bar is equal to dv bar upon t. This is the definition of instantaneous acceleration. Or we define this acceleration or instantaneous acceleration in terms of x-axis and y-axis. Therefore, a bar is equal to dv bar upon dt or dvy upon dt into j cap plus dv bar x upon dt into I cap. This is the average acceleration in terms of x-axis and y-axis. Or this can be written as a bar is equal to dvx bar upon dt into I cap plus dvy bar upon dt into z cap. Therefore, a bar is equal to d upon dt into px bar into I cap plus d upon dt py bar into j cap. A bar is equal to d upon dt, px means dx upon dt into I cap plus d upon dt, py means dy upon dt into j cap. square x upon dt square into I cap plus d square y upon dt square into j cap. This is the instantaneous acceleration. A bar is equal to d square x upon dt square into I cap plus d square y upon dt square into j cap, where I cap and j cap with the unit vector along x axis and y axis. Now we define the component where the values of ax and values of ay. Ax means the component along x-axis and ay means component along y-axis. The ax is nothing but d square x upon dt square and ay means d square y upon dt square. Here ax represent the acceleration along x-axis, ay represent the acceleration along y-axis. Now the magnitude of instantaneous acceleration. The magnitude of instantaneous acceleration is given as a is equal to under root d square x upon dt square bracket square plus d square y upon dt square bracket square. Using this equation, we can write, we can determine magnitude, or a is equal to under root ax square plus ay square. This equation also gives the magnitude of instantaneous acceleration. Now the direction of instantaneous acceleration is defined by this equation or this equation. Then direction of instantaneous acceleration will be, this is the magnitude of instantaneous acceleration, and the direction of instantaneous acceleration is given as the component tan theta is equal to dvy upon dt divided by dvx upon dt. Therefore, this dt cancel, or finally we get tan theta is equal to dvy upon dvx. Using this equation, tan theta is equal to dvy upon dvx, we calculate the direction of instantaneous velocity. Now in same chapter, we discussed another equation. That is the equations of motion. Equations of motion for an object. Equations of motion for an object traveling. Object traveling a plane. A plane with constant or uniform acceleration. We define the three kinematical equations or equations of motion traveling with plane with constant or uniform acceleration. Therefore, let u bar be the initial velocity at t is equal to 0. If time changes 0 to t, the velocity also changes and velocity become v bar, and this is called final velocity. Now, if the acceleration is constant or uniform, then average acceleration and instantaneous acceleration is same or equal. जर acceleration सेम असेल, कॉन्स्टंट असेल, युनिफॉर्म असेल, तर ॲव्हरेज acceleration आणि इंस्टंटेनियस acceleration हे वेगळे नसतात, तर हे एकच असतात. मग therefore we simply define the acceleration. If acceleration is uniform, then the average acceleration and instantaneous acceleration is same. Therefore, acceleration is given as v bar minus u bar upon t minus 0. Therefore, a bar is equal to v bar minus u bar upon t. Or this gives a bar into t is equal to v bar minus u bar, or v bar is equal to u bar plus a bar into t. This is called the first equation of motion. V bar is equal to u bar plus a bar into t, where v bar means final velocity, u bar means initial velocity, a bar means acceleration, and t is the time. Now, in case of displacement, the displacement of particle at time t or at starting point t is equal to 0 and the time is varying, t is equal to 0 to t, then the displacement is say s bar, and average velocity will be v bar average is equal to v bar plus u bar upon 2. This is the average velocity. आपण त्याला मराठीमध्ये सरासरी म्हणतो. फायनल velocity v bar, इनिशियल u bar, तर average म्हणजे त्याचा मध्य किती येईल, u bar plus v bar upon t. And also the definition of average velocity is nothing but displacement upon time. Velocity is equal to displacement upon time. Therefore, displacement s bar is equal to v bar average into t, or s bar is equal to values of v bar average, v bar plus u bar upon 2 into t. Therefore, s bar is equal to v bar plus u bar upon 2 into t, but we use value of v bar from equation 1. Therefore, s bar is equal to u bar plus a bar t plus u bar upon 2 into t. Therefore, s bar is equal to u into u, 2 u bar into t upon 2 plus a bar t square upon 2. Or this gives s bar is equal to 2 to cancel, u bar t plus half a bar into t square. This is the second equation of motion. S bar is equal to u bar t plus half a bar into t square. Now, these equation first and equation second. This is the first kinematical equation or equation of motion, and this is the second kinematical or equation of motion. We can write these two equations of motion in case of x-axis and y-axis. In case of x-axis, this can be written as v bar x is equal to u bar x plus a bar x into t. And in case of y-axis, v y bar is equal to u bar y plus a bar ay into t. We write this first kinematical equation or equation of motion in terms of x-axis, that is bx bar is equal to ax bar plus ax bar t, and in case of y-axis, vy bar is equal to uy bar plus ay bar into t. And we write second equation in such a way that along x-axis, s bar x is equal to u bar x into t plus half ax bar into t square. And this equation is written along y-axis, that is s bar y is equal to uy bar into t plus half a bar y into t square. This is the equations of motion of object traveling with plane and constant or uniform angular acceleration. This is about x-axis. This is x component, and this is the about y-axis.